Welcome to lecture number 15 of Signals and Systems. The topics covered in today's lecture are convolution, sum and examples. So to summarize the previous class, we understood what is a convolution sum and how to derive the output of the convolution. So we took one example and we could able to solve it graphically as well as with some other alternative ways. We'll proceed to the next example. So there is a question given like this. Example 2.1. There is a multipath communication channel where the system is defined as y of n is equal to x of n plus 1 by 2 x of n minus 1. Okay, so here they have given the input as this one: 2 for n equal to 0, 4 for n equal to 1, minus 2 for n equal to 2, 0 otherwise. So this is the question given. Now there is a system given. This is a system. Of course, it is output and input. For output and input combination equation, we call it as a system. System given and input separately it is given, but there is no h of n given. To find out h of n, we have to do some extra work here. So first let us write x of n. X of n in terms of sequence. At n equal to 0, your value is 2. This is for n equal to 0, comma. For n equal to 1, it is 4. For n equal to 2, it is minus 2. This is x of n. Now to find out h of n, I had told you that for the system operator, when you feed the input as a delta function, your output what you receive is itself is a h of n. This is what we are supposed to do now. So what I'm supposed to do? I have to substitute x of n with delta of n. So same thing I'll be doing now. So what I do is, so this y of n becomes h of n if I substitute x of n with delta of n. Wherever x you have, replace it with delta. Wherever y you have, replace it with h. So in this fashion you will get it. So this one, if I write it in terms of the equation or the sequence, this would look like h of n would look like n equal to 0. When n is equal to 0, this will be having area equal to 1, strength equal to 1. Rest everywhere it is 0. So only at n equal to 0, this is 1. So what is its weight, or what is its constant? 1 is the answer. So when this will be 0, this will go to 0 only when n value is substituted with 1. So when n is 1, this whole goes to 0. Delta of 0 is 1. So 1 into half is half. So we could construct x of n as well as h of n. So once we have these two things, we can go for further solution. So now I'll just write the table. So this is h of n. If I fold it, this is index 1. If I fold it, where it will go? Maximum is minus 1. That's it. 0, 1, 2, 3, 4. You can stop. Okay. So x of n, I'll write x of n or x of k. So x of k is 2, 4, minus 2. 2 starting from index 0. 2, 4, minus 2. Rest everywhere, fill it with 0. So I mark it where other places you have non-zero, zero values. Only here you have non-zero values. Now with this we need to proceed further. So I have to perform h of n minus k or h of minus k plus n. For n is equal to 0, it is h of minus k. For n is equal to 0, it is h of minus k, means you have to fold it. H of n is there. If I substitute minus k, it should be folded. If I fold it, whatever I had at index 1 will come at minus 1. 1 by 2 comes over here. 1 will be here. Rest everywhere 0. Now for n is equal to 1, h of minus k plus 1, you have to shift it onto the right. This becomes 0. Half, 1, 0, 0, 0. For n is equal to 2, h of minus k plus 2. What happens? 0, 0, Shift one more time. So for n is equal to 3, h of minus k plus 3. 0, 0, 0, 1 by 2, 1, 0. So for n is equal to 4, h of minus k plus 4 will result in the window you can see that all zeros I got. So at this point you need to stop. Similarly, if I try to shift on the left, what happens? So at n equal to minus 1, h of minus k minus 1, take the reference of minus h minus k, half goes off, 1 comes over here, rest everywhere it is 0. So here also it is 0. So last two case will result in y of 4 as well as y of minus 1 will result in 0. So this no need to verify because it will result in y of n is equal to 0 in this place. So I have to consider only these things. So first, for n is equal to 0, y of 0 should be computed as 1 into 2 is 2. Similarly, for y of 1, half into 2 is 1 plus 4 into 1 is 4. This is 5. This is for y is equal to 1. For y is equal to 2, half into 4 is 2 plus minus 2 into 1 is minus 2. This will result in 0. Y of 3. Y of 3, half into minus 2 is minus 1. That's it. Here in both the case it is 0. So y of n is given by 2, 5, 0, minus 1. So here is the index. That's it. Very simple. If at all if you want to verify, you can verify this also. Let me take the verification also here. Verification is very simple. X of n is given by 2, 4, minus 2, and h of n is given by 1, 1 by 2. Index is here. So take 2, multiply here, 2 and 1, 2 ones are 2, 2 half 2. Next take this, 4 ones are 4, 4 half is 2. Next take this one, minus 2 into 1 is minus 2, minus 2 into half is minus 1. So take the diagonal. That's it. This is y of n. What do you get? This is 2. This is 4 plus 1, 5. This is minus 2 plus 2 is 0. This is minus 1. That's it. This is verified to be right. This is verification. So it is resulting in same answer. So that's it. That's it about the convolution sum of this example. So similarly, you can have n number of such examples. Let me give some assignments for you. You can try it by yourself. So few assignments for you. Assignment, because it's like a repetitive solving, the same manner you can solve it. You have to convolve it. X of n is given by 2 delta of n minus delta of n minus 2, sorry, n minus 1, and h of n is given as 1, 3, here is the index, 2, minus 1, 1. Please try it. If you fold it, this is index minus 1, this is 0, 1, 2, 3. If you fold it, maximum that comes over here is minus 3. Okay, and this also you should take care. This will come at 1. Okay, so this is one of the assignment. Find out y of n, convolution sum. Y of n is nothing but x of n convolved with h of n. Okay, so second assignment, I'll give one more assignment for you. Simple assignments, not difficult at all. X of n is equal to 1, 1, 1, 1, 1, comma 1, comma 1. H of n is 1, comma 2, comma 3. Okay, so verify this and find out x of n convolved with h of n. There are few more varieties of convolution sum. We will check how to work on those things. I'll mention the zeroth number here. 1 second. Yeah, it is here. So first variation that I'm considering is convolution sum with impulse function. Convolution with delta of n, impulse function. Okay, very first example quickly, these all are very simple. X of n convolved with delta of n will result in summation k is equal to minus infinity to plus infinity delta of k x of n minus k, or else you can also write x of k delta of n minus k, that is also okay, which is equal to delta of x of k delta of n minus k, both mean same. It will result in x of n. Always remember, any signal convolved with impulse signal gives the same signal. Remember, any signal convolved with impulse signal gives the same signal. Okay, okay. So next, second one, very simple. So I can give any such example. For example, x of n convolved with delta of n minus n naught. So this will give you, refer this and tell me what comes as the answer here. Please come up with the chat box. Here also it is signal convolved with impulse signal, but slightly modified. It is convolved with time shifted impulse signal. So what should be the expected answer? Here we are getting x of n. Here you will get the answer as x of n minus n naught. That's it. Remember, because delta will result in 1, delta will result in 1 when the value in the parenthesis goes to 0. When it will goes to 0? When n value is n naught. Okay, when n value is n naught, then only this will goes to 0. So that's why we have to write x of n minus n naught. So this is the third one. Third one, x of n convolved with small verification. I will consider even step function also. Okay, u of n. In this case, what happens? These all are like one more question, teasing questions. Summation k is equal to minus infinity plus infinity x of k u of n minus k. So in this case, what happens? So always remember, u of n is 1 only for n is equal to n is greater than or equal to 0. Now similarly, if I ask you to write u of n minus k, u of n minus k will be 1 only for when it's the starting value, the step. This is a step function. When that step will be taken, that we need to identify. That step here, the step is taken at n equal to 0. Here the step will be taken when this quantity goes to 0. When this quantity goes to 0, so when n minus k is going to 0, when n is, I write it as greater than or equal to 0, because equal to 0 or greater than, it will continue to be 1. So n greater than or equal to k. So in this case, this particular function will be having non-zero value, or else I can also write it as k less than or equal to n. Why I write like this? Because summation is with respect to k. So hence summation k is equal to minus infinity till n, till n. If I write only in this region, your u of n minus k will give you non-zero value. Rest everywhere it is 0. 0 multiplied with x of k is 0 itself. So no need to compute it. So that's why only in this range. So this is less than or equal to n. K less than, this is a higher limit. So lower limit is minus infinity. So minus infinity to higher limit. So this is a k's range. So that range I am writing, in that region only your u of n minus k's value is 1. Okay, so that's why your answer for the third one is k minus infinity to n x of k. That's it. This is the third answer. Now similarly, fourth one, the slight modification, x of n convolved with u of n minus n naught. So in this case, what you are supposed to do? Summation k is equal to minus infinity till plus infinity x of k u of, in place of here, u of n minus n naught minus k. This should go to 0. N minus n naught minus k greater than or equal to 0. So n minus n naught greater than or equal to k, or else k should be less than or equal to n minus n naught, and k's lower limit is minus infinity. So this becomes summation k is equal to minus infinity till n minus n naught. In place of n, I am having n minus n naught. X of k into 1 or just write x of k. That's it. So this is the answer for fourth one. I hope it is clear to you. Now fifth one. Small variations, but these things needs a lot of concentration. Impulse function convolved with impulse function always result in impulse function itself. Because at n equal to 0, both these things are 1. So at n equal to 0, this will be also 1. So that's obvious answer. Now we will, I'll show some variations here. Delta of n convolved with delta of n minus 2. In this case, what you are supposed to do is, I'll tell you the trick. Whenever you have an impulse function, convolved with any other signal will give you the other signal itself. That thing, that statement already I had quoted the very first example. This is the answer. And now one more variation. Delta of n minus 3, delta of n minus 2 will result in, remember, what you are supposed to do is minus 3 and minus 2. You just take a sum of it. Minus 3 plus minus 2 will result in minus 5. Just write that. Just write this. I'm giving you this hint. Delta of n minus 3 convolved with delta of n. This is as good as the second one that I've taken. Any signal, that signal itself will come over here. And one more. Delta of n minus 3 convolved with delta of n plus 2 will result in delta of n minus 3 plus 2. Sum of these two. Minus 3 plus 2 will result in minus 1. That's it. Delta of n minus 3 convolved with delta of n plus 3 will result in delta of n. That's it. Okay, so this is the fifth question. Very simple. All these are very simple one. Now we'll move on to comparatively the complex we will increase the complexity. I'll take the new one. So sixth problem. So in book it is problem number 2.2, Simon Higgins. Y of n is given by u of n convolved with u of n minus 3. What's the meaning? The meaning is, it's like I have been given two signal, x1 of n convolved with x2 of n. You can assume it as x of n convolved with h of n as per our wish. So we have two signals. We have been asked to convolve it. So it can be written as summation k is equal to minus infinity till plus infinity x1 of k x2 of n minus k. This is a formula. In place of x2 you can write even h. It doesn't matter. Okay. So now what we have to do is, you have to take this into account. If I take this into account, if I write it here, summation k is equal to minus infinity till plus infinity, in place of x1, what do I am having? In place of x1, I am having u of n. So u of k I have to write. In place of x2 n minus k, I have to write u of n minus 3. In place of n, I am having n minus 3 minus k. So in place of n, I am having n minus 3. So there is a two equations here and there is a summation. In this case, what we are supposed to do, that is what we need to identify. Please listen it carefully. If you understand this concept, you will definitely understand whole lot of convolution sum. Okay, so I am telling you very important thing now. We have to decide the limits, lower limit and higher limit. Always remember, u of k extends from 0 to plus infinity. You know it. U of k, I write it here. U of k will look like this, amplitude 1. U of minus k will look like this. So negative from minus infinity till 0. This is from 0 till infinity. This is the difference. This talks about u of minus k. This talks about u of k. So u of minus k and u of k. So what we have to do is we have to identify lower limits and higher limits. Always this defines lower limit and this defines upper limit. Okay, so we will just go through it. Here what we are supposed to do is u of k is equal to 1 for n greater than or equal to 0 and 0 otherwise. That we know. Similarly, u of minus k, you know that it is 1 for n less than or equal to 0 and 0 otherwise. Okay. Now, if I ask you to tell me u of n minus 3, u of n minus 3 is 1 for whatever I am having here, like whatever k, here k should be greater than or equal to 0. Here n minus 3 should be greater than or equal to 0, or else n greater than or equal to 3. If minus 3 is taken this side, plus 3. For n greater than or equal to 3, u of n minus 3 will result in 1 or else 0 otherwise. U of n minus 3. Now what I'm doing is I'm taking this u of n minus 3 minus k. Why I'm taking this? Because I'm having that equation here. This is 1 for, write all these things, n minus 3 minus k greater than or equal to 0. Now I'm finding the limits for k. N minus 3 greater than or equal to k, or else k can be written as k less than or equal to n minus 3. This is the upper limit. Upper limit of summation we decided. What about lower limit? Lower limit is u of k. This decides lower limit. This decides upper limit. Upper limit. Okay. So lower limit is, it is k greater than or equal to 0. For k greater than or equal to 0 till n minus 3. So that is the range. The range of k. Range of k is k. What you are supposed to write? Here k should be less than 0. Greater than or equal to 0. Then less than or equal to n minus 3. This is the range. Once this range is found out, the next work are very easy. So I proceed with the problem. These all are prerequisites of unit step function, whatever we studied. Now I proceed with this. Y of n is equal to summation k is equal to 0 till n minus 3. In this range, why I found out this range? In this range, both u of k and u of n minus 3 minus k will be non-zero values, or it will be 1. Unit step function it is. In the, for u of k, it is always greater than or equal to 0. It will be 1. For this one, it will be 1 only when k is less than or equal to n minus 3. So I have decided this range. In this range, the combination, the product is always 1. So that's why this is 1 into 1. This will result in summation k is equal to 0, n minus 3, 1. Means, what's the meaning? Adding 1 so many number of times. How many number of times? N minus 3 times. And there is some standard form for this. What is that standard form? We had come across this in first chapter. I'll write it here. Summation n is equal to 0, n minus 1. This is a standard form. If I add 1 till n minus 1 times, it is whatever upper limit I am having plus 1. Whatever upper limit I am having plus 1. It will result in n. So similarly, if we apply here, what you get? Whatever upper limit I am having plus 1. It will result in n minus 2. It will just result in n minus 2. Y of n value is n minus 2. That's the answer. This is the answer. And for this, the answer is valid only for n. This range you need to write. Only for n greater than or equal to 3. For 0 for n less than 3. That you should remember. That you should remember. Because n value will be, the n value will also be written here. Should also be written here. This is also, this will complete your answer. Without this, your answer is not complete. If I take n is less than 3, your answer will be 0 itself. If I take n equal to less than 3, this will never result in value 1. The value of u of n minus 3 will be 0. That's why range of n also should be declared. Range of n also should be declared. So for n greater than or 3, your y of n is non-zero. And for n less than 3, y of n is results in 0 value. So hence you have to write this. The other way of writing it is y of n is equal to n minus 2 n minus 2 into u of n minus 3. This is also correct. U of n minus 3 means it will be having 1 only for n greater than or equal to 3. It's as good as writing in this fashion. This is what you are supposed to learn in this subject. N minus 2 for only in this range. We can write in this form also. Okay, so this is the example 2.2. Now we'll consider one more example quickly. Example, this is example 2.2 from the book. X of n is given as u of n and h of n is given as alpha raised to n u of n, where alpha is in the range 0 to 1. So this is a given problem. Why it is given in this range? Because there is some standard form. I'll write the standard form here. There is some standard form. Summation n is equal to 0 till n minus 1 alpha raised to n. If I get somewhere in this fashion, the formula is 1 minus alpha raised to capital N. You just concentrate here. Upper limits plus 1. Capital N 1 minus alpha for alpha not equal to 1. If alpha is equal to 1, then your answer is 1, because alpha equal to 1 means 1 itself. Summation of 1 is, you already know that, upper limit plus 1. That is what is written. Okay, this is a standard form. Now we'll go for the solution. The solution goes like this. So y of n is equal to summation, or else I'll write it as x of n convolved with h of n. This is plus k minus infinity to plus infinity x of k h of n minus k. H of n minus k. So you can either write in this fashion, or else you can also write. I normally prefer the easier method. I'm going with easier method. Okay. So other way also, this method also okay. Easier method is minus infinity till plus infinity, because for this, if I go on applying alpha raised to wherever n is there, I should replace it with n minus k, alpha raised to n minus k, u of n minus k. That will be complex. Here it is very simple. That's why I interchange it. I take h of k here, x of n minus k, I write it. Both mean same. So we have already witnessed it. Both are equal. Now what we are supposed to do? We take it in this fashion. First what we are supposed to do is substitute k equal to minus infinity till plus infinity. It is alpha raised to n. I have to write k because n is replaced with k, u of k, and x of n minus k. N should be replaced with n minus k, u of n minus k. So these things we need to decide. K's lower limit and upper limit can be decided. Before that, we will decide on the range of n. Decide the range of n first. I'll take one more ink. Range of n. If you follow perfectly the steps, it will be very easy. Range of n can be found out as, when you just check here, when n is less than 0, you can check here. Consider x of n. When n is less than 0, what happens? Your y of n will be 0 itself, because both way it is u of n. When n is less than 0, y of n result in 0 itself, because it's a multiplication of x of k into h of n minus k. When it is 0, for n is equal to less than 0, so it will result in 0 itself. So that's why no need to check for this range. For when n is greater than or equal to 0, y of n yields non-zero value. So this decision we should make first, and then we should proceed with the range calculation of k. We need to identify k's range now. So what is the range of k? With this I define lower limit, with this I define the higher limit or upper limit. So u of k's upper limit is, we already know, u of k, here I write u of k is equal to 1 for k greater than or equal to 0. This already we know. Okay, so k is greater than or equal to 0, then only this will be 1. Now for lower limit, u of n minus k is equal to 1 only for n minus k greater than or equal to 0. K I take it on the other side, I'll get it in this fashion, or else I write it as this, k less than or equal to 1. What is the range now? Range of k is 0, k greater than or equal to 0, k greater than or equal to 0, I am writing in this fashion, less than or equal to n. This is the range of k. Now we have to proceed further. I had left y of n is equal to summation. What's the range now? K is equal to 0. Here what's the range? It is n. So alpha raised to k. U of k and u of n minus k both have become 1. That's why it is just summation k is equal to 0 n alpha raised to k. For this there is a standard definition. What is the standard definition? So whatever upper limit is there, add it 1 and your answer is done. Alpha is not equal to 1 because it is less than 1. Here it is given. So it is in this range, it is not equal to 1. So hence you apply this formula. This, according to this formula, answer is 1 minus alpha raised to, add 1 to the upper limit, n plus 1 divided by 1 minus alpha. That's it. So this is the answer, and this is true only for what range of n? Only for n greater than or equal to 0. That range we have already decided. So this can also be written as y of n is equal to 1 minus alpha raised to n plus 1 divided by 1 minus alpha, enclose it in bracket, and you can write it as just u of n. It is nothing but u of n exists only for n greater than or equal to 0. So this is the answer. And you can take an assignment like, what if I consider this one? What happens? That also will result in right answer. Only thing is you will get alpha raised to n minus k, that you should take care. It will result in same answer, but always prefer the simplest method. Okay, prefer the easy method. One last problem we'll take. So x of n, so problem 3 I guess, x of n is equal to u of n, h of n is equal to 3 by 4 n u of n. So it's, you can just connect it with previous problem where this is alpha and alpha is given as 3 by 4 and it is well within the range of what is mentioned, right? So simple, you can solve in the same manner. In your examination if it is asked, you should solve in the same manner. So wherever you have alpha, from here you need to start. Replace alpha by 3 by 4, 3 by 4 raised to k, write it. Range of n you need to write, range of k you need to write this. Wherever alpha you have, write 3 by 4, 3 by 4 here, 3 by 4, 3 by 4, always. So, but here already I have done the same thing. To avoid the repetitive work, I'll copy this answer from here. Wherever alpha is there, I replace it with 3 by 4. So what I do is, the question is not at work, question is like, determine output at n is equal to minus 5, 5 and 10. Solution. So I'll take the previous formula, alpha formula. In place of alpha, I'm supposed to write 3 by 4. Here it is n plus 1 divided by 1 minus 3 by 4 u of n. So this is a solution which you have already done. So this is the answer. That's it. Now I'll solve this one. For n equal to minus 5, what is the answer? Here u of n is there. For n less than 0, y of n value is 0. So for it is minus 5, n is less than 0. Hence y of minus 5 is 0. Make that, don't directly substitute here and compute the answer. Of course it will result in answer, but when you say u of n exists only for n is greater than or equal to 0, hence it goes to 0. Similarly, for n equal to 5, if you substitute, you get y of 5 is equal to 1 minus 3 by 4. 5 plus 1 is 6, divided by 1 minus 3 by 4. It will result in 3.288. And n equal to 10, y of 10 will result in 1 minus 3 by 4 raised to 11, divided by 1 minus 3 by 4. So it will result in 3.831. You can cross check at your end. Simple problem. Okay. So one more assignments for you to solve it. First, y of n is equal to half raised to n u of n minus 2. See here, it is not just u of n minus 2 convolved with u of n, convolved with u of n. So this is first assignment. Second assignment, simple one I'll give. Y of n is equal to half raised to n u of n convolved with u of n. This you can relate with the problem that we have solved. U of n, in place of 3 by 4, just I have 1 by 2. You can solve it by yourself. Okay. So then one more example I'll take. X of n is alpha raised to n u of n, and h of n is beta raised to n u of n, where alpha and beta both are less than 1, mod less than 1. Mod less than 1 means even it exists in the range 0 to 1. That's the meaning. Let me write it. Okay. So for this, you need to compute y of n. Convolve with h of n gives you y of n. Compute that. That's a assignment for you. Please solve it and come up with the answers in the next session, before the next session. So with this, we are concluding today's lecture number 15. We'll see you in the next class. Thank you.